Hello and welcome, everyone. Thank you all for joining us today for this live stream event. Before we begin, I'd like to quickly review just two items. Our code of conduct. So the Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you are mindful with your commentary, remaining professional and on topic. Our event guidelines. This session is recorded. We are obviously streaming to YouTube right now. It will be available directly after the session concludes for on-demand access if there's anything that you wanted to circle back to and reference. If you have any questions, do feel free to drop them into the chat. And if you have not been on a YouTube live session before and you're asking, where is that chat? You do need to have an account set up on YouTube to interact there. So now is a great time to do that. So for today's session, the Reactor is pleased to be joined by Jared Rhodes, a Microsoft Azure MVP. Today he'll be discussing Homelabs, how to have a private cloud on a budget. So let's pull up our speaker. Just one moment. Hello, Jared. How are you? Welcome.
I'm wonderful. How are you?
Doing good, doing good. It's finally, I'm in New York. I don't know where everyone else is tuning in. Let us know where you're watching from. And it's finally warm out and sunny. It's been a long time since that happened. Yeah, welcome. So I will pull up your slides here so that you can intro yourself and get started.
All right. Well, thank you very much. And I should let the audience know you all saw that that nice fancy animation and all the upbeat music and all that. I don't have any of that. I've got like slides and I'm going to teach you some stuff, but I don't have all that amazing stuff. So I want to bring the expectations back down before I get started. So this is Homelab, private cloud on a budget. All right. So my name is Jared Rhodes. I'm a principal at EPAM Systems. So EPAM is a publicly traded consulting firm. We do engagements for enterprise clients. My primary role since I've started there has been solution architecture and enterprise architecture, helping customers with Azure, getting enterprise controls set up, doing migrations, building new products, that kind of stuff. I'm a Microsoft Azure MVP. Primarily focused on the IoT and edge computing space. And I'm a Homelab builder. So about 2 years ago, I kind of got locked inside and had a bunch of spare computer parts laying around, and I had to entertain myself. My wife now has a big, beautiful garden, and I have a ugly bunch of cables everywhere. And also, I'm a professional Teams call joiner. My day usually consists of clicking the join button and clicking the hang up button. So if you need any advice on how to do that, I'm here too. Okay, let's talk about using a Homelab. So in this talk, we're going to split it up into 3 sections. 1 is going to be using the Homelab. 2, we're going to talk about the software that you're going to be using in your Homelab. So we're looking for free software or free-ish software. And then finally, we're going to talk about how do you acquire the hardware if you have to buy hardware and what you should look for and all of that. So a Homelab, if we have to define it, is a lab at your home. Or maybe a better definition would be it's servers available on a private network, that you own or have complete control of. And a Homelab doesn't have to be fancy. It could just be an old laptop. Most of the use cases I encounter involve something that could be solved by taking an old laptop, plugging in an external hard drive, and putting multimedia on the hard drive. It can be an old tower server or a tower or your desktop that's maybe outlived its usefulness. You could go all the way, though, and start buying racks and using rack mount servers, rack mount equipment. And then finally, you could build your own data center if you really wanted to, but the data center is probably outside the scope of this talk. I should note that this is a hobby. Whether you decided to buy a boat, get into sewing, buy little plastic figurines, whatever it is, it's a hobby. And you will burn through spare cash and spare time to facilitate it. So what should you consider when you want to get into the home lab hobby? I'd say the number one concern is probably your power usage. I think people really underestimate how much juice they're going to be pulling when they set up an entire home lab and start hosting different servers or whatever else they're deciding to do. I know I myself ran into that. I'm at my office right now. I rent one, and I set up rack mounts in the server closet, and it didn't take me long. I'd say about one router, one modem, 2 switches, and 3 servers, and I had already overloaded a 20 amp circuit and had to get more circuits put in. We'll talk more about noise later, but understand that if this is an actual home lab, this is something you've put into your home, it's not going to be quiet. If all of a sudden you start running workloads on there and the fans kick on, it may sound like, and honestly, it sounds like a little jet is trying to take off in whatever server closet you have that in. Whenever I was having my power expanded in my server closet, I told one of the servers to turn off, and when it went to shut down, it kicked on all the fans, and the electrician came running out, and he was like, "Hey, I don't know what's going on in there, but I'm gonna have to step out." And it's just that loud. So if you're going to do this at your home, you might want to let your significant other know and set it up appropriately so that they don't have to deal with this loud, noisy, power-consuming thing. It's also going to generate a lot of heat. I mean, a lot. If you go with rack mounts, you will also be amazed not only at the noise, but the amount of heat that it puts out. I haven't run the heater in my office ever since they were installed, not through the entire winter or anything. It constantly is too hot in here. In fact, I had to close my doors to do this online presentation. I'm sitting here, and I know by the time this is over, I'm going to be sweating just because of how much heat it puts off. The air conditioner just cannot keep up. It takes up space. Even that laptop with a plugged-in hard drive takes up space. You have to have somewhere to put it, and you're probably going to want to run an Ethernet cable or something. You want to make sure that it's not going to be, grabbed by the kids as they run by and see a hard drive or something plugged in, and they just want to yank it apart. And as we said on the previous slide, cost. If you start getting really into it and you're buying custom, network cards to fit into an old server that you have, rack mount, because you wanted to run a specific blah, 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 it adds up quickly. And honestly, make sure you look at the alternatives for whatever you're looking to do before you end up buying a bunch of equipment and plugging it in at your house. There's a never-ending supply of cloud offerings available. So look at some hosted services prior to diving into this hobby. So that was my disclaimer for anyone looking to get into this. Now I'll be more upbeat about the actual hobby. So let's start the first section where we're going to talk about using the home lab. In this section, we're going to talk first about use cases of the home lab, and then we're going to talk about some setups and constraints. And if you're watching this on YouTube, when we get to the setups and constraints, they are going to be, in some cases, elementary, but it's something I feel like I have to cover to make sure that we can move to the next section. I don't want anyone who didn't know that to get left behind. Okay, so first is the use cases. So what can you do with this? Well, you can try out different hardware configurations or custom hardware. So I do the IoT and edge computing work, and that's sort of how I got into doing home lab. If you've got older equipment, older hardware that you need, let's say it's not TCP/IP capable, and you need to get it on the internet to run. So you've got an older piece of hardware, and you need to build adapters or have a gateway or something else built. It allows you to learn about all these different hardwares. And learning these different, and I'll say sometimes old hardware, is actually really interesting to me to teach people, because like with COBOL programming, as less and less people are in the job market able to do it, if you're the person who still understands how to set up those ZFS arrays and an old Solaris server, well, then you're probably making more money than everyone else who's building websites. So it's nice to be able to use that different hardware in your home lab to learn things for future employment. networking. So you can learn different things about networking configurations and setup. And networking is another lost art. There are still practitioners of this. I won't call it archaic magic. I'm trying to think of a good word to call it, but of this not regularly used magic anymore. Since most people in college aren't even taught as much about the networking stack and are just pushed into using cloud offerings. There is a gap there that I think most engineers aren't exposed to anymore. So you can actually set up and learn networking. And if you want to get into that side of the industry, you can have your own little lab to set up different networking technologies. For most people on a call about Microsoft technologies, you're probably looking at development technologies. So different stuff that you haven't tried yet, whether you want to try a Kafka server in the middle of a solution or something else that you want to try out at work or on a personal project. Having a home lab allows you to easily set up and use different development technologies in your solutions. Private clouds and edge computing, which is sort of my focus and my primary use case for this. I basically I grew up in the middle of nowhere, and for me, having the control and having the localization of what I want to do is important. If you're an enterprise, public clouds make perfect sense. If you're a startup, public clouds make perfect sense. But I think there's a combination there where still private clouds and edge computing have a very strong use case in the industry and for personal use. And then another thing that I do is data processing and archiving. I could go into that forever, but it's just something that I personally do. Once you have your own home lab and you want to store your terabytes or up to a petabyte of data, it's actually much cheaper to do that locally than it would be in a public cloud hosted solution. And then finally, for a lot of people, they want to just host websites or to be honest, for a lot of people, they just want to be able to turn their old hardware into money in some way, and hosting websites, e-commerce, that kind of thing is usually how they try to do it. But the primary use case is people want to create their own home media servers, and that it's obviously for their home videos or pictures of their kids or whatever, and for maybe a few little bits of media that they have the copyrights to, obviously. But for most people, it's to have a home media server. And for most home media servers, you can probably get away with, again, an old laptop and an external hard drive. You just need a large storage space, so you can go out and you can buy a 16 terabyte hard drive, plug it into your laptop, set up something like Plex or MB, or just have a flat file server, and there you go. You have your whole home media server already set up. Some people like to host their own game servers. Again, something that's I'm probably showing my age, but I liked LAN parties, and I like being able to host my own server so that once a month when my friends and I finally get a chance to play a game together, we can not use any of those and play something else. There's the archiving and data processing. So underneath that, you can try out all the different data storage technologies that you may not have access to at work or that you want to learn about. So any of the different database types, any of the blob storages, unstructured stores, or any of these specialized, let's say graph or statistical stores that you'd want to try. Like me, you can do data archiving. The first thing that my scripts to set up the entire home lab from scratch do is they set up a apt mirror, because I don't like the idea of not having access to these repositories locally. I want them local. I don't want to have to go and download each time. So I can go and pull things all during those kickoff scripts. They create an app mirror, and then they use that app mirror, and then they use all the Git repositories that I want to use are pulled and cloned locally. You get the general idea. I really like to have everything on the local storage instead of trusting that the solution that I do not have control of will always be there. I even if I use old tech, I'll actually do a web archive of their entire documentation just to make sure that if they ever go offline, I've still got it all available to me. And then finally, big in our industry right now is machine learning. So you can test out different machine learning algorithms on your local cluster to learn the technologies and learn more about machine learning. And it's also sometimes a lot cheaper to do it locally than it is to run it in the cloud. But you should know that heat, noise, and power usage will probably go up exponentially if you start running machine learning algorithms, training models on your local lab. And finally, as I said, people like to host websites. Some people like voice servers, video servers, and chat applications. I think I've set the tone for you. And again, for our YouTube users, these setups and constraints, they can be elementary. So if you want to skip this and go ahead. But what I want to talk about here is for those who set up a home lab that want to have it publicly available on the internet, I want to describe how that happens. So at a very basic level, you at your home or at your office have paid for an internet service provider to give you internet access. And what can happen is other computers out there can send packets to that internet service provider who will then route it to those computers at your office or home, and vice versa. You send packets out and they route it for you. That means they probably provided you with a modem or, usually a modem router combo that's either fiber or coax cable plugged into the wall. And that's how all of the internet happens automatically at your house. If you're going to build a home lab, my very first suggestion would be to split that modem and have your own router behind that modem so that you have much better control. Because what I get from AT&T and Comcast is not only slow and frustrating, it also lacks numerous controls that I would like to have on any network that I control. Most likely, if you're trying to turn this into e-commerce or game servers or whatever, you're probably not going to have people try to remember your IP address. So you be using DNS lookups so that they can get whatever domain you bought and type that in blah-blah-blah.com and be routed to your IP address. If you want to purchase a domain, there's plenty of registrars available. I won't go over them all. I use GoDaddy. I know that there's for a longest time, everyone told me oh, don't use GoDaddy. Use Namecheap or, blah, blah, blah. I've just used it forever. And every time I go to use something else, the prices are exactly the same. So I might be doing something wrong. I might be doing something right. I'm not sure. But for a registrar, you want to buy, I own jaredrhodes.com. I go there. I purchase jaredrhodes.com. They have name servers, and I set a record in the name server to point to my IP address. That works for me because I have a static IP address. You may be assigned a dynamic IP address by your ISP. So if your internet service provider doesn't have a static IP address allocated to you, that could mean that in the event of an outage or a firmware update or anything, they could change your IP address. So if you went and you did DNS, you set it up appropriately, then your service provider could change to a different IP address and none of your publicly facing domain setup works. There are dynamic IP address software solutions. I think the biggest one is NoIP, but I have a list of a couple of different ones that you can try. This particular part of the talk works better in person. But basically, you run this application and it will update your DNS record dynamically so that if your ISP changes your IP address, the resolution still points to your IP address, even if your IP address changes. And one final note, if you want to expose across multiple IP addresses, you have to pay for those. If your ISP, they'll sell you a block of 5, 10, 20, however many IP addresses you're willing to pay for, I'm assuming to a limit, but it can get expensive. Instead of doing that, use the IP address that you have and make use of port mappings and your reverse proxies. Those two might be outside of the scope of this talk, but basically you can use different ports to forward to different services so that not all of them have to be mapped to the exact same port that they are locally. And you can use reverse proxies to resolve domain routes when someone hits your IP address with a web request or a browser request or whatever you want to call it. Okay, so in this section, we talked about use cases for the home lab and setups and constraints. So let's move into the free software or free-ish software. In this section, we'll talk about how we're going to discover that software. How do we find it? And then we're going to talk about the uses, like what do we need to use this software? So we're looking for free software. All right, so before that gets removed from YouTube for some copyright violation, free software is not open source software. I don't want to get on a soapbox to discuss this. Software can be free and closed source at the same time. Software can also be open source and not free. So just understand there is a distinction there. Free software is not open source software, and open source software is not free. Okay, how are we going to find software for us to use? So I usually, I'm pretty simple. I go to 4 websites to find software that I want to test out in my home lab if I didn't hear about it from some other source. So one would be the Apache Foundation. The Apache Foundation, I don't know how else to put it, but sometimes it gets referred to as the place where software goes to die. And there's a lot of software that it has been practically abandoned on the Apache Software Foundation, but not all of it. And there's still good stuff in there. And to be honest, if you can find some older projects that might not be readily updated, you can pick them up and update them yourself for whatever you need, or you can just use whatever they are updating. But you can go to the Apache Foundation website and you can go to projects and you can sort by or you can pick by category. And then you could look, let's say you wanted to use CouchDB, and it has information on CouchDB. And then you could just go and discover, here's the CouchDB website. So it's going through and maybe finding something that you're looking for to host. If you're looking for a private cloud, I remember Mesos was really big at one point, even though I can't remember what it does. Cluster management that can run Hadoop and Hypertable and Spark. So just go to the Apache Foundation. You can look through software that way by category. Look for the category that you're looking for. So if you're looking for big data, or you're looking for some IoT project, they have tons of software available there. This is hard to navigate just because I have to keep changing these slides. So excuse the lack of smoothness right now. Okay, next is the Linux Foundation. I like the Linux Foundation not just because it has Linux in the name and it runs the Linux kernel and all that. But what I like about the Linux Foundation is when you go and you look through stuff that's coming out in Linux, you find things that are just little gems that can change your world. I mean, if you were to go through here and you were to have found the Berkeley packet filter when it first was, starting to get traction, for me personally, I had no idea like what the usefulness of it was. But by following the projects that were created off of that, it really let me see that we now had this sort of eventing tool off the kernel that was very useful to see what was going on without opening up any security issues. So that's why I like the Linux Foundation. You can go in here and you can find little changes. I don't want to call them little, but you can find things that later become huge in the industry and have a good understanding of it at the right time, for at least for those of us who do it, as a career. So let's just go here. We'll look at networking and edge, and we'll just say, I don't know any of these. Here we go. This is the Berkeley packet filter. So Berkeley packet filter, you can read about it, how it works here, and look at all the different stuff that comes off of it. Or you could go and click on KubeVirt and whatever it is. And they have an intro video, and you can learn more about KubeVirt. Just different ways to learn about different technologies. I will say for the Linux Foundation, if you're looking for just, I want to click a button here and see software and be able to install it. The Linux Foundation does have projects that aren't one-to-one with technologies, or with, I should say, code base or software you can install. Some of them are managements of policies, like what's this? This is the ONAP policy framework. I don't think there's going to be anything in here that I can directly install, but it probably is a committee that is in charge of some framework or some standard that's used within the industry. So that's the only thing to note about the Linux Foundation projects. They don't one-to-one with software. So if you're looking specifically for software to run in your home lab, you may not find it on the Linux Foundation website. Okay. Next, we would look at GitHub. All right. I think you all know what GitHub is, right? GitHub is this place where people put all their source code because it's cool to put your source code here. And so we can go and we can just type in awesome. Go to GitHub, type in awesome. Here's an awesome data, awesome public data sets. And if I want, I can go here, and I said we were discovering software, but we'll segue into discovering big data sets. So I can come in here and I can just look, and here's an entertainment data set, top streamers on Twitch. I don't know, finance. Here's the Google Finance, Google Trends data, and we can just go and we can click on one of these. This is data.nasdaq, and so I'm assuming somewhere here I could get catalog data to run through machine learning algorithm that I wanted to run in my Homelab. If I didn't want to look at big data, we'll type in awesome again. And boop. I'll just search for awesome. Oh, I'm looking in this repository now. That's why I can't find it. All right, so we'll just type in awesome again. And we'll look all over GitHub. Interesting topics. Awesome tools for Windows. Okay, you get the idea. I'm kind of wasting time by going through GitHub too much. You get the idea. You can come here and you can find these awesome lists of software and go through them and hopefully host them in your Homelab. The final one is this one I've been using. It's not complete, so take it with a grain of salt. But I use this awesome sysadmin at sysadmin.libhunt.com, and I can just go to projects and I can close the ad. And I can go in here and most popular tools are Code, Kubernetes, Elasticsearch, Redis, Ansible, Atom. You know, if you've had to deal with client sales calls right now, these are all very familiar. So you could just, here's Rocket Chat. I think it looks like Slack, and then you go in and you can self-host this. And again, open source doesn't mean free. I believe this is open source, and there's a community install that you can do for free, and you can have your own Slack. Just know that once you want to actually use this, it's not free anymore. You have to pay for it. This is awesome sysadmin. We can go and we can just look at the categories, and I could just go in and we just saw that one in messaging. So here's Let's Chat, some other project. And again, it also looks like Slack. So you get the idea. We can go through and find all these different softwares that we want to host in our Homelab for whatever reason we discussed earlier. Other ways to discover software, and how I actually got started discovering all the different stuff that I wanted to try out. Now, I wouldn't say force upon my clients, but I don't know if there's a better phrasing for it, is by going through things like Ansible Galaxy. So if you don't know what Ansible is, it's a configuration management tool, and they have a repository of pre-built configuration scripts, and it's called Ansible Galaxy. And you can go through there and you can find what's popular, what are people configuring on these servers, and how they're used. The Docker registry, which I actually won't go into because I'm sure you're all very familiar with Docker registries, but you can search there for the most popular softwares or Docker images that are used. Like Ansible, Puppet is a configuration management software. They have their own repository called Forge. Same thing with Chef. They have Supermarket. Bitnami creates these pre-configured solutions. So when I'm talking about these configuration managements in the software, like let's say I wanted to try Postgres as a server. If I use these, it's not that I'm setting up Postgres anymore. That's pretty simple. We can do that with a few commands on a Linux box. What I'm talking about here is for something like these, I'm setting up a cluster, and some of these scripts will automatically get me set up with a Postgres cluster that has any number of primary nodes, replication nodes, and witnesses to have a full solution set up for whatever you're trying to do in your Homelab. If you go to these, you'll see the software available that you can run in your Homelab, usually for free, but check. Okay. So what do I need to use this Homelab? Well, you're going to need operating systems, networking, probably cloud host, some fundamental systems, and then you can finally explore that software. The list of what I'm about to talk about is not comprehensive. Could you imagine if I tried to do a comprehensive talk on the number of different software projects out there that you could use? Okay, so you're going to need an operating system. You're probably going to be using Linux because the title of this section was free or free-ish software. I've been using Debian. It is this is what I got started using, and I've been using it ever since. So everything I do is Debian based. In fact, now I'm getting so far along in my career that when I have to use anything else, like I have to go to a client and use Red Hat, it feels kind of unfamiliar. So this stuff is free. The community insists that this stuff be free, and it runs most hardware. You should understand, you might buy some stuff off eBay, put some of these Linux OSs on it, and then the hardware, but maybe the network card just doesn't work. Maybe it can't figure out how to use that because the drivers aren't available. And so at this point, I have a very good understanding of how to use the non-free software drivers on Debian, but it took a lot of pain to get there. So understand, these are the Linux. It's probably what you're going to want to use. It's what your clients probably use. Use Linux. Get to know it. This section was called free or free-ish. And I'm not a lawyer. And I'll say this a couple of times throughout the talk. I'm not a lawyer. You can use Windows Server. Windows Server is not free. You got to pay for it. I'm sure there's some deals out there that Microsoft has or whatever. And you can maybe use those deals. I'm not sure. But I'm not a lawyer. You can use the Windows Server for up to 6 months on the trial license. And at the end of that trial license, and I'm not a lawyer, you can just take a system level backup of that Windows Server and then reinstall Windows and then reload that backup. And I don't know if you violated the license, but it doesn't like shut you out or anything. So I'm not a lawyer though. You can use Unix. I use Unix as well as Linux in my servers, just because I use TrueNAS as a as my NAS. I use TrueNAS. That's about my only exposure to Unix. I don't know enough to really talk to it, and if I say anything bad about it, a Unix fanatic will appear in my office while I'm giving this talk and start throwing holy water on me. But you can use Unix. I use Unix in mine as well for TrueNAS, and it has its purposes. We have so I can't really talk about like cloud operating systems without talking about ESXi and VMware. So you can use ESXi. I'm not a lawyer, but I think you can use ESXi. I think they have it free for up to 8 cores on one machine. You can only do it for one machine or something like that. But the ESXi isn't what they want you to pay for. So if you already have VMware Workstation or something else, you can install ESXi on the hardware that you're looking to use, and then Workstation works directly with ESXi. I'm going to have to expand this section now that I've learned more, but buy networking equipment. It's a lost art. And you can buy a router and a couple of switches and probably get it in under $100 on eBay. I looked into doing was it IP Fire IP? One of the Linux networking OS, and I was going to build it custom, and it was a lot of work, and I really didn't. I'm going to get into that. I just didn't want to spend the money yet. And there's so many cheap alternatives to getting your Homelab network set up. I mean, you just buy an old router for like $30 off of eBay, and you are golden. It is probably faster than whatever you bought from your ISP, and it costs you nothing. Cloud host. So we've got our hardware. It's running its operating system. Now we've got our networking set up because we just bought networking equipment. That made it a lot easier. And now we're going to set up our cloud host because we want to be cool, and we bought more than one server, and we need to be able to manage them. So I can't talk about these cloud hosts without talking about Kubernetes. I mean, I can't, because it is so pervasive in the industry right now. And I'll say for a Homelab, I don't know if Kubernetes is a good fit. It's not a bad fit, especially if you want to learn Kubernetes. Like it's a good fit in that case. But it's not. You don't have to have it. I don't want you to feel like you have to use Kubernetes. You can literally just install the OS and install things on top of it without having to have something like Kubernetes with all of its management capabilities. It's meant for a scale that would be outside of this talk if you needed Kubernetes. However, you've got the hardware, you've got the OS set up, you can learn Kubernetes. And I from these client sales meetings, Kubernetes is what people want. You can use Metal as a Service, which is from Canonical. I haven't used it, and I'm not 100% sure exactly where it fits, but I believe that you use Metal as a Service, you install it right on top of the OS, and it acts as a coordinator for creating virtual infrastructure easily so that you can on-demand create whatever Linux, Windows, Unix, whatever virtualization you need, and it coordinates all of that right out of the box, automatically. Personally, I use Proxmox just because it falls into the category of free, and it has a UI that makes it easier to manage things. I script everything, and then I want to look at something, and that's when I just, for me personally, for my home lab, I need a UI just so I can look at things easily instead of having to go through 5 layers of command lines that don't look as good to me. So I use Proxmox. It's built on top of Debian, and they have a backup server already built in, which is also another reason I went with it. So you can just, for free, backup server, and then this for the cloud host. And all it really does is exposes the UI on top of LXC and KVM. OpenStack is a really popular cloud host, and I believe it's just Kubernetes. I don't use it personally, but a lot of clients have it, and I believe OpenStack is just a Kubernetes style host to manage your workloads. You can use LXD, which is just a cluster management server. I shouldn't say just. You can use LXD, which is a cluster management technology on top of LXC. So LXC is like Docker. It's Linux containers. I should say they're both containers, and they started from the same origin. LXD is on top of that as a cluster management tool on top of LXC. And I talked about, this isn't free. This is the only thing on the way I really have to point out is not free, at least not that I know of. But we talked about ESXi earlier, and I didn't have anything to manage the cloud for ESXi. So you need vSphere, vCenter, those items to actually manage the cluster that you're setting up. Okay, so I've got operating system running the hardware. I've got networking equipment so that the hardware can talk to one another. And now I've got some sort of cloud management on top of that so that I can manage all of those pieces of hardware that can talk to one another. Now I need my fundamental systems. Well, this doesn't really count as a fundamental system, but it does, but it doesn't. So the first thing that I would build, even before the operating system and everything else, would be the network access storage. And that's just because in the home lab that I'm going to set up, I'm not actually going to put disk in the other servers. I'm only going to have the network access storage and run everything else off of sort of a PXE boot or something like that, and have all of my storage centralized. We'll talk more about that later, but I just note that's the first thing I'm going to build. Then I'm going to need some sort of authorization or LDAP server. I'm going to need some way so that I can access my servers without being physically connected to them. So I'm going to probably set up a VPN. I'll probably want my own internal DNS so that things resolve appropriately and that I can handle, blocking ads on my home network or whatever I want to do. I want my own certificate authority so that everything within my network doesn't have to be SSL over Let's Encrypt. I'll actually have my own certificates that I can manage. You'll want email, and I'm speeding up here just because I'm running out of time, but you'll want email. You're not going to be physically there with your servers when something bad happens. Windows, Linux, Unix, they're all set up so that you can easily have the operating system use a SMTP client to send out emails to an administrator on some event. So you're going to want that set up. And then finally, you're going to want logging. You're going to want that for the network layer, the OS layer. You need to know what's happening on your network, and you need to be able to look at it retrospectively. Because if you do expose your network to the internet, you've got this home lab, you've got it, it's cool, set up, you like it. You're going to need to set up that logging so that if anything happens, a hacker gets in, you can at least show that, look, this wasn't me, I didn't do this, that's not my stuff. Okay, once you've done all of that, now you can explore software. Just for me, I messed up my animations. Just for me, this is what I'm running in my private cloud. Most of it's set up. Some of it I'm still setting up. But these are all the things that I like to run just so I can either use them, learn about them. Some of them are just infrastructure. But you can run all kinds of software. And this is the list that I just pulled together quickly. I'm running a whole lot more Not all of it's actively used. It's just stuff that I wanted to try. I wanted to see what it was like. I wanted to see how I could use it. My office setup, as I said, I have a NAS. It's running TrueNAS. It's got about 60 terabytes on it and 60 hard drives in it. I run a cluster of about, I think it's more than 7 now, but 7 Proxmox servers that are pretty much right now all off just because I don't need them. I use Wacom LAN to save on my power bill. Proxmox backup, just so I can have backups on both the NAS and Proxmox and this backup server as a form of redundancy, so that if I need to roll back anything or for any reason pull up old data that I accidentally deleted, I've got backups. That's at my office. At my house, I have another much smaller NAS that I use as offsite backups. And then finally, I use Azure for the last resort of backups, just to make sure that I have that level of redundancy. Okay, so that was software discovery and uses. And again, I'm going to be speeding up just so that I can try to make this within time. Hardware acquisition. This is what a lot of people actually come to these talks for. So, well, what do you need? In this section, we're talking about what do you need, where to look, and what to look out for. So what do you need? Well, the first thing you need to do is you need to understand what you're building this home lab for. Don't go out and try to buy hardware for every generic use case or to mimic an enterprise environment. That's not what you need. That's not what you're doing. Try to understand your use case so that you don't burn through thousands of dollars for no reason. Plan accordingly. My first bit of advice is to buy nothing. Don't buy anything. You've probably got an old laptop or an old computer sitting around that you could get 90% of whatever you're thinking about doing done on that old computer. These enterprise level, whatever's, it's too much. You probably don't need it. Just use an old computer. Don't have that? Use an old Raspberry Pi or buy a Raspberry Pi and you end up with like $100 total setup. It's cheap. It's easy. And if your amount of requests to your server is like 1 every day, what do you need more for? And as I said earlier, I'm not a lawyer. I mean, you could steal stuff, but I'm not a lawyer. So, talk to one before you get into anything. Okay. So I personally am doing the whole mini data center setup. So what do I need or what do you need? It depends on your use case. But we'll go over everything and we'll try to do it quickly. So for your network layer, you're probably going to need a router, a modem, and a switch. Right? The router, you're going to need to set up all of the rules for your network. The modem, you're going to need to talk to the ISP so that you have internet access. And then finally, the switch is for scaling out your network easily. You're going to need storage, SSDs, you're going to need some solid state drives, maybe. I mean, I don't use any. You're going to need some hard drives. You could set up a NAS or a SAN or some direct access storage, and you're going to need backups. And we're going to go into these in the next couple of slides. You're going to need backup power. Quick story, anecdote. When I moved into my first house, it was sort of a newer development area, and somehow they cut the trees on the road in a way that one tree sat right over the power line. And every time the wind blew hard enough, it would just tap the power line. And when it would tap the power line, my power would flicker. It didn't take long after losing my first computer's power supply to a windy day of it just bumping that. And every time my computer having to restart, for me to learn that you need backup power. Not because you need hours or days of utilization after the fact, but you need backup power so that whenever you have power flicker, you don't have to reboot the entire machine. You might pull a lot of amps, so you might need to consider the total power that you're going to be using. If you're putting this in a closet in your house, just make sure that it's not on a circuit that's also powering a grill or some other air conditioner or something internally. And finally, it produces that heat. You need airflow, you need cooling. Servers, I think, is what people are most familiar with because of the having their own PCs. It has RAM, it has power, it has CPU, and it has networking. Okay, again, networking is that lost magic. So let's talk about some of the router features you're going to want. You're going to need to be able to log everything that you can on your network so that you can see when things are accessing things they shouldn't be or what is spamming traffic across certain networks. You'll need to set up firewalls. if you start doing subsystems or subnetworks or subnets, you're going to need to set up firewalls so that you can make sure that when those things are cross-communicating, they're cross-communicating appropriately, and to make sure that if you have any external access to your network because of an incident, that things are properly protected. You'll need a VPN because you'll want to access your files, your data, your servers, when you're not physically connected to the same network. And you'll want to be able to have this physically isolated. As I said, my background in getting started in this was IoT and edge computing. And you don't want that home network where your kids need to get online to attend school or whatever. You don't want that on the same thing that you're plugging all this random hardware you're buying off of eBay on. You want those separate. You don't want to have to explain to your significant other why the internet's down for a day because you didn't isolate the network and something you bought is a spam bot and you can't figure out how it infected everything. Isolate the network, see if make sure that your router has like VLAN support or something so that you can have the same router and physically segment your networks. You're going to need storage. I use TrueNAS, I use ZFS for the actual file system underneath it. ZFS itself is probably a little bit outside of this talk, but I use that because I want to avoid using RAID cards, and I'll talk about the RAID cards later. You're going to want your network access storage or direct access storage. So direct access is what most people are familiar with. You just plug the hard drives into the computer. It plugs directly into the motherboard or the RAID card, and it just sees those disks. It's what we're used to. Network access storage you're probably also familiar with because we have file shares or whatever at work. Just for your home lab, your data center, it's a little bit fancier. You're doing more than just exposing things over SMB. You're exposing them over like a network file share, a Unix file share, and you're actually using those to act as the disk of the other servers so that they don't have to manage their own disk. They can use a shared, more powerful disk setup. And then finally, there's a storage access network. If you got to that point, you're outside of the scope of this talk. But at the enterprise level, you're getting off that NAS and you're going to redundancy and distributed storage that is, again, outside the scope of this talk. As far as your disk goes, you're going to want your hard drives or your SSDs or your NVMe's. I use hard drives pretty much exclusively. I don't have high-end data throughput needs in my home lab. I actually have storage needs more than anything else. So when you're looking at those, you're going to be looking at hard drives that are either SCSIs or SAS drives or SATA drives. And for most home labs, if you're not looking for that speed, you'll just get SATA drives because they can have so much data. That's what most desktops have in them. If you are looking for speed, don't go straight for SSDs and NVMe's. That speed has many layers in the hard drive space prior to the SSD or NVMe's. And also SSDs and NVMe's are this way that we go back to that burning money thing. Yeah, these cost a lot usually. I should note for the SSDs, be careful on how you set those up if you use them in a network access storage configuration or if in ZFS. Be careful. Read how you're supposed to use them. Don't think that you can just create a write log off of a RAID of SSDs. I did that. They were all dead within 2 days, and I lost the entire cluster. Read the documentation. That's all I'm saying. You can buy expansion arrays. So these are basically they house a bunch of hard drives. You can plug in an expansion card into your server. You put this expansion array near it. Then you wire into that card into your server to the expansion array. And now that expansion array is just disk available to your server. It's a very easy way to expand out your total data set. And there's a bunch of them out there because there was some cryptocurrency that needed expansion arrays and it went bust. And so there are a bunch of cheap ones. Don't buy the hard drives, though. Just buy the array. If you do have this network access set up, this shared storage, you can then set up better compression, deduplication, and caching. once you have everything shared and you're starting to set up these pools for each of these separate use cases, you can now become more fine-grained on exactly how the data is held so that you can either maximize for space, speed, or whatever else you're looking to do within your use case. And then finally, take backups. I mean, even if you're just doing whatever simple project or whatever side thing you're doing, I mean, if I've never been more defeated than when I lost work. If I did something and a drive died and I lost work, I feel like I'd spend 100 hours making sure I had backups to not lose 1 hour of work, just because how defeated I am once it happens. Have the backups, have the redundancy. Um, I'm trying to think if I talk about redundancy later in the slides, but have redundancy. So if you have a drive die, right, make sure it's set up so that that one drive doesn't take out everything you've worked on. You can't recover your data. I think I've actually I've talked about the uninterruptible power supplies. I've talked about your airflow needs. And I've talked about amperage. So I'm gonna skip this section. When you go to buy a server, you're going to need a few things, and you're probably familiar with all of these if you've ever built your own PC. You're going to need power supplies, obviously. You're going to need a CPU or CPUs. You're going to need network. You're going to need memory, RAM. And finally, you're going to need disk. Maybe you can get away without the disk by just having it do a special configuration so that it boots without its own local memory, own local disk. But this whole thing was to tell you that you need redundancy. You don't need a power supply, you need power supplies. If one power supply goes out, the actual physical power supply that's in the server, if that power supply goes out, you need a backup power supply. That way your server just doesn't crash. And if the OS is appropriately hooked into the firmware, you can now get that message emailed to you that, hey, I've lost a power supply. And you can know that you can go in and easily change that out without having to take the server offline. Same thing with the network, if you have a network card die. And then the same thing for a disk, if they're in the appropriate RAID array. Memory and CPU, maybe you can change them out, but the point that the point the computer dies is some things are just dying. But you do need that redundancy in these parts within the server. And then obviously outside of that, you're going to need redundancy at the server and infrastructure level when it comes to internet connectivity, power supplies, and everything else. But that's, we're getting more into the data center side of things at that point. Okay. What most people come to the talk for, you're probably looking at your watch like, oh, you got like 6 minutes left, and we're just now getting to where to look. I'm going to have to speed through this, but the one thing I do want to focus on is electronics recycling. Companies need to get rid of their data centers. They go to electronics recyclers. They yank out all of the hardware, and then you now have access to that hardware. They actually, if you go on eBay or any of these websites, that could be one electronics recycler that has multiple storefronts across multiple web fronts, that if you go to direct, they don't have to pay for all those listing fees or do all that work. You can go in there, you've got a credit card, and you can say, I want that. The server racks that I have in my office right now, I bought for $100 because I was willing to drive them away from the electronics recycler and they didn't have to ship them anywhere. Government surplus is always suggested. I've never seen how that works. Every time I go there, it's already all sold out, but government surplus, government closes a division or something, and they've got tons of hardware, and they just bulk sell it. Same thing goes for university surplus. I also don't take part in that because I always feel like I'm taking from some broke student somewhere. But universities also have the same sort of thing. They go through giant amounts of hardware all in one rotation and sell it all off in bulk. The Facebook and Marketplace, you can go there and you can find tons of hardware. But if I go back to that other slide where I'm not a lawyer, I don't know how stolen it is. So I don't really go there either. And then any of the refurbishing websites or I use Unix Surplus a lot. Any of those are pretty good. If you know what you're looking for, you go there. And just in case you're afraid you're going to misconfigure your server or buy parts that aren't compatible, you can buy fully refurbished solutions. And then finally, eBay. Pretty much everything I've put up to this point sells on eBay, and eBay could be a one-stop shop to just find whatever you're looking for. Okay, I'm going to very quickly go on what to look out for. When you're buying stuff, what kind of connections does your motherboard provide for the hard drives? Does it have a RAID card? If that RAID card fails, how hard will it be to replace? I have a RAID card, right? So if I have a RAID card, that RAID card dies. Now all those disks only can work with that RAID card. How do I recover my data? I have to go buy another RAID card. Is that RAID card even sold? Can I find it? If a hard drive fails, how hard will it be to recreate the cluster? Do you have to turn off the server? Is it hot swap? How does that work? And then what is the maximum physical storage supported by the RAID card, and what's the maximum memory supported by the RAID card if you're using a RAID card that has its own memory? Are you primarily reading or writing? So you need to know whether you want SATA, SCSIs, or SAS or SSDs, what redundancy is needed, and can you use NAS instead for all the hard drives? A big one, does the server trust the hard drives that you're buying? So the server, I have a bunch of Dells and HPs, and they are vendor lock-in, whatever. They do vendor lock-in. If you plug in the wrong hard drive, the Dell will just see that and go, I don't know what that is. It might be too hot. And turn your fans on full blast. It's loud. It uses 30% more power in my case, and you end up having to go back and buy the hard drives that are certified by them. There's some guy out there. I don't know his name, but he's awesome. For some reason, he's the hardware guy, and he keeps a running tab of what servers work with what hard drives. What are your network throughput needs? Is your network card fast enough? Is the switch and router fast enough? Does your network card do packet filtering? Does it handle it? Does it do direct pass through to the CPU? Does it have enough ports for your configuration? Does it have redundancy? How hard is it to replace your network cards? What are your memory needs? This isn't a question. This is a note. Use Ecc Ram. You have a bunch of stuff going on that server. Don't let one app crash a server. Don't use DDR2 memory. It is too hot and too power hungry. And then understand what you're buying. Understand if it's a UDIM, RDIM, LDIM, and what configurations are supported by your motherboard. This one got me into a lot of trouble and a couple of hours of debugging, and I had one stick that was the wrong type, and that server was in the wrong configuration for that. And then, harvest your old RAM. Sorry, I'm kind of trying to get to the end. What power levels do you need? What compute power? You mostly know about compute power. Okay, real quick, bad buys. I want to get this to you before I run out of time. So bad buys. Don't buy a used UPS unless you're buying it without the battery at a hugely discounted price. Most of the cost of an uninterruptible power supply is the battery. If that battery has been used, it could be near its end of life, and you've basically bought nothing because you're going to have to buy the battery again just to get the UPS working. I speak not only from general knowledge, but personal experience on that one. I've told you about the RAID cards. Beware. Hard drives, like I said, there was some cryptocurrency that required hard drives. If you buy hard drives used from that thing, they might last a month, a day, a year. You don't know. So be careful about used hard drives, because if they weren't treated well, they won't work well. And be careful if you're buying fossils. If you're buying something that's so old you won't be able to replace parts, or things won't be compatible, or that you're going to have to find some wizard to tell you how to use it, don't. Okay. We talked about what do you need, where to look, what to look out for, and I don't have time for this cool video I put together. Okay, this is the question slide. I have a list of online stores, but the link that was shared by Rebecca in the chat is this full talk as a blog post where these are listed. And that was me, Jared Rhodes, and we talked about using the Homelab, free software, and hardware acquisition. All right, it is now, my hour is up. So back to you, Rebecca.
Hello. How's it going? So if anybody has any questions, feel free to ask. There was, if you have a moment, Jared, to look through the chat, some people talked about the hardware they currently have and own. A lot of Raspberry Pi commentary in there. I highlighted a couple of comments in the starred tab if you have a chance to kind of look at that.
What am I looking at? Oh, starred. Here it is.
Yeah.
All right. Build a Homelab using VMware. So I'm reading from Tim Summers. Hello. Actually, Tim, give me a second before I read your talk. I'm going to drink some water. He says, hello, in Edmonton, Alberta, Canada, I built a home lab using VMware, Hyper-V, routers, and switches in the past. Due to a flood, dismantled lab, and just haven't had the time to get it back together. Yeah, I actually worry about that a lot. When I get out of this office, because my server closet that I've got all the stuff and those hours sunk into is in, I'm in the side of a hill. So that's why it's so hot in here. I can't get the air out. But I also worry because I did have a flood when we first started renting this office right in the front. And it didn't get all the way to the server room. But man, I would be more than upset. Let's see.
Yeah, not too many questions, more just comments that I thought were interesting.
I'm using Firecracker and micro VMs on my 3 laptops. Awesome. Yeah. I just had, I got 3 Macs that are, they just hit the age to where now they say you can't update to the latest Xcode, which absolutely makes them useless to me because they were all from different mobile development projects. And yeah, so they are now going to be nice little Linux boxes. All right. Tim Summers again. I use the lab for software development, producing server network training for a national college. Really looking forward to the session. And he's now wanting to build a lab with a subset of resources for Java development. Yeah. And what Tim's doing is exactly what I'm thinking and what I'm doing. I mean, for a lot of people out there who are, they come to the reactor to learn about different stuff, but I feel like the best way you're going to learn about these technologies is doing what he's doing. If you go out and you buy that or not buy, if you go out and you set up that server or whatever technology you want to use, Kafka, you want to use some sort of new logging framework, Elasticsearch, big data, whatever, that's going to be the best way to learn in my experience, because once you fight the battle, you'll know for next time, you'll know what not to do, and you'll know the mistakes that other people are going to make. Ross G. Saunders says, if you can find a Pi at the moment. I've been working with Microsoft for so long. I've got like 22 Raspberry Pi 2s that I should probably figure out how to get rid of, because Microsoft, before they got rid of the evangelist program, was just like, here, Jared, take these and go do whatever. We don't care.
I'm sure people would appreciate.
Yeah, I should probably list those. Knock the dust off of them. How about Dell Micro PCs or HP Microservice? I'm not 100% familiar with them. I will say that when I got started, they weren't Dell Micros, but it was an old Dell. It was like a Dell T 100 T 110 or something like. Anyways, it had its age, and that's how I got started on this. That's how I learned about ESXi and what's allowed for free, because I just set it up on there. And yeah, again, for most of the use cases, you're not running an enterprise. You don't need, supercomputer type setups or 1,000, a load for 100,000 customers. It's probably going to be you, and you can probably walk over and turn it on when you need it and turn it off when you don't. So yeah, if they support Linux or Windows, you have everything you need to get started with the Homelab. All right, and Mustafa says, I'm using a Homelab to learn Kubernetes clustering and various new tech on top. Yeah. When we do our client engagement sales calls right now, I mean, everyone wants Kubernetes. They want to migrate to Kubernetes or whatever. And learning on that locally and how to set it up, I feel like will be a nice, what do I call it? A nice job security blanket for a long time, because those systems, once they build out, I mean, they're investing millions of dollars into them. They're not going to throw them away, and they're going to need these Kubernetes clusters managed for the next 15 to 20 years. So I think it's great. And if you set it up in a home lab, you'll immediately start learning how different it is than what people who use it expect. If you think about it from a hardware perspective, it's very different. It acts more like an operating system would on top of the cluster, whereas other cluster management software thinks about the hardware. It thinks about the operating system having more management over its workload. All right, and then Sebastian says, nested virtualization, Supermicro board X10, E5, VMware as a host system. All right, yeah, that should work.
Awesome.
again, from what you've got right there is enough. It'll cover pretty much every use case you probably have. And I know this is the Microsoft Reactor, but I when I got started, I really liked VMware as my host. The problem is if it's one thing that Windows does when you're getting started that VMware doesn't is Windows has the drivers. They have the drivers already built in, and if you're buying older hardware and you start putting ESXi on there, you have to find like what version and what drivers, and you got to get in the command line and get it all working. But if it already supports it, I kind of like it better.
Awesome. Well, it seems like this was a really good session. There was a lot of people out there that are trying to do their own home labs and building them out. So thank you so much for being a part of today and the Reactor programming. I appreciate it.
All right, thanks
And
for
thank
having
you
me.
for joining us, and hope to have you back again. Yeah, at this time, everybody, if you're not part of the Reactor yet, do feel free to check us out. We're on Meetup. Find your local Reactor location. We have 12 physical spaces around the world. And we're always rolling out content. So this time, I think I'm going to wrap it up. Thank you again, Jared. Thank you to our audience for tuning in.
All right, thank you.